Hello, Bio30, and welcome to the next video on the thyroid. You've learned the thyroid loop, looking at both calcitonin and PTH and thyroxin. Now we're going to talk about some of the diseases and review that. So today, again, how does the thyroid release thyroxin? How does it help our metabolism? What is calcitonin and PTH in regards to the bones? Can you diagram the feedback loop of both thyroxin, PTH, and calcitonin? That's key. You've seen the video. Can you do it? Now we're going to identify the glands that release the hormones, talk about what thyroxin does in regards to hyper and hypothyroidism, and identify some diseases of our thyroid. So let's talk about when things function right, the thyroid. So when things function right, okay, when they go good, the thyroid's a great gland. It's a great thing to have. It's located at the base of your neck in the front of your trachea, as you can see there, kind of a little bit of a butterfly shape, kind of wraps around where your larynx is, just in front of it. It is stimulated by a thyroid stimulating hormone that comes from your anterior pituitary. Now, your thyroid has two really important hormones that it secretes, thyroxin and calcitonin. All right, two very, very key ones. T3 it's like triiodide something hormone. You don't need to know it. You may see the word, but you don't need to know it. You need to know T4, which is thyroxin, and calcitonin. Now, thyroxin is super, super important because thyroxin regulates all the cells in your body. It works on every cell in your body because it works on your metabolism, how fast we burn calories. So thyroxin is going to be one of those hormones that touches on almost every cell in your body. Calcitonin, on the other hand, works mainly on bones. We call it calcibone-in, meaning it takes calcium from your blood and puts it back into the bone. So calcium into the bone, or calcitone-in, putting it into the bone. So you have seen this thyroxin feedback loop in a different version, but essentially there is some sort of stimulus, such as like you eat and your metabolic, or sorry, you haven't eaten in a while, or you're hungry, or something happens and your metabolic rate decreases. Your hypothalamus will release the TRF, which is the thyroid releasing factor. This is not a hormone, it's a releasing factor. It just talks to the anterior pituitary. That anterior pituitary produces TSH. The TSH goes to the thyroid makes thyroxin, and then we have metabolism increasing in all cells. All right. That is essentially what thyroxin does. At any moment in time, we can have a feedback loop saying, hey, hypothalamus, stop releasing that factor. Hey, anterior pituitary, stop making TSH. You're going to have a feedback loop that stops that process once your metabolism has increased and your body cells. There's a problem. There's always a problem. So when things go wrong, thyroid. When things go wrong, it goes wrong fast. No, it doesn't. It just goes wrong and it can be bad. So thyroxin is what we're going to focus on. So the thyroid itself releases a hormone called thyroxin. And when you do not have enough, so too little, too little, okay? We call this hypothyroidism. Now, hypothyroidism is the low metabolic rate. We're very, very tired because obviously our body is not going to ramp up because we're not digesting, we're not metabolizing food. We're less active, we're intolerant of the cold, we get cold really quickly, we have very dry skin. Weight gain is a big one because, again, your body's not properly metabolizing. But then the one that is really important is the thing you see in these pictures, and that is called a goiter. A goiter is essentially the enlargement of your thyroid gland because there is no thyroxin being produced. Now, in order for thyroxin to be made, it's not just as simple as TSH saying, hey, make me some thyroxin. Your body also needs something called iodine. Iodine is required to make thyroxin. You can find it in fishes and in salt. So along with TSH and iodine, we can make thyroxin. But if we cannot make enough thyroxin, if our anterior pituitary just keeps hitting us with TSH, okay, and keeps hitting us, and our body's not making thyroxin, okay, what happens is your thyroid gets enlarged as it's trying to produce more and more thyroxin, but it can't because there is nothing to make. So in this case, the negative feedback system isn't working properly because normally if we don't have any thyroxin to make, it should tell our hypothalamus, hey, stop telling the pituitary gland to make TSH. But for some reason, it is broken and it's not getting that message. It thinks we're making thyroxin when we're not. The opposite side to the story is when thyroxine is too high, so hypersecretion. Hypersecretion is shown with a high metabolic rate, so people tend to be a little bit thinner. They can't sit still, they're always moving, they're very warm because their body's constantly metabolizing. And eventually they can suffer from something called Graves' disease. Now, Graves' disease has an effect on the soft tissues around your eyes, especially, where eventually they cause your eyes to almost protrude out of the sockets because it is you're getting thin and your eyes, the tissues around it are thinning. So finally, let's talk about the control of calcium. So I said that the thyroid gland also releases something called calcitonin. So calcitonin is released by the thyroid because there is a stimulus of some sort that calcium is too high in the blood. Our thyroid gland then produces calcitonin. It targets bones, kidneys, and small intestines, and it takes the calcium that's in our blood and puts it into our bones. That's great. There's another part to this story because if we're putting calcium into something, we also want to take calcium out in case we need it. So PTH, or the parathyroid hormone, which is found on the parathyroid glands, which are essentially on the very front of the thyroid, will trigger if we do not have enough calcium. Now, we know at this point calcium is really important for things like nerve impulses, right at the synapse. Sodium comes in, pushes calcium down. The vesicles then can go to the end of the synapse, open up, and move forward. If we don't have calcium, we can't do that. If we don't have calcium, we can't have a muscle contraction because troponin is covering actin by being bound to tropomyosin. Calcium removes tropomyosin when it binds to troponin. So calcium is used in so many more ways than just strengthening our bones. So we need it in our blood as well. So the parathyroid hormone comes from the glands that are the parathyroid glands. And what they do is they are producing PTH, or the parathyroid hormone, when we do not have enough calcium. So our calcium blood level is low, so we want to increase it by taking it away from the bones. So this is kind of one right from your textbook that it looks like. It says, here we are in homeostasis. Oops, sorry guys. Here we are in homeostasis. We have perfect calcium levels in our blood. All of a sudden it gets too high. Something, maybe drink milk, I don't know, gets too high. So the calcium rises, it triggers the thyroid to release calcitonin. We then take calcium into our bones and the calcium levels fall back into homeostasis. Or what could happen is we now have too little. We put too much calcium in our bones. So if it drops, okay, we go to these little guys right here, these 4 little glands at the front of your thyroid, the parathyroid hormone. And what we do is we reach into those parathyroid hormones the parathyroid glands to reach for the parathyroid hormone, my goodness, which breaks down and reabsorbs calcium into the blood. And then kidneys reabsorb calcium from the urine and the absorption from calcium in the small intestine. So we take calcium back into our blood to maintain homeostasis. So those are the 3: thyroid, how we make thyroxine, what goes wrong with those, calcitonin, and PTH. If you have any questions, please let me know.